Slash asterisk graphics not rendered in HTML asterisk slash pop-up print user exe print pop-up exhibit core0 atom task srv cmd line ap set task user cmd line srv task con user task con jobs hnDLR job run 1 exe cmd line c job nodes are one of 5 types. User applications deal with text or MSGS. Job run 1 will call a function, spawn a task or execute some text src code. Number define jobt underscore text underscore input 0 / task text. Feed std in number define jobt underscore message 1 / task message. Post message number define jobt underscore exe underscore str2 / task exe. Compile and execute src code text number define jobt underscore call 3 / job k. Tell MP to call function number define jobt underscore spawn underscore task 4 / spawn. Tell MP to spawn task. Several other routines include a call to jobs HNDLR, that gives them powerful ability to execute certain CMDs. File, keyalloc.dd. Key allocation C# for definition of scan codes. See key map for a detailed list of key commands. When you are at the CMD line, editing documents, browsing documentation, and help, entering items in forms or in menus, the DOLDoc editor handles keys. It allows you to define your own key HNDLRS in a myPutKey function. If you choose, you can cache keys, overriding the default HNDLRS. See docPutKey. The following is an overview of key allocations and free for user configurations in your myPutKey, HNDLR, except for Alt _ undo. There are a few examples predefined, but you can change them if you wish. And handled at a system level, not by the CDoc editor. I reserve the right to alloc these, but in the meantime, you can define your own HNDLRS with TrelawSpset. They operate either in an interrupt environment or in the window MGR when it queues KVD MSGS. You can do raw output. HNDLRS take a scan underscore code as an ARG. Autocompletes local words. Autocompletes dictionary words. Jumps to SRC code. Jumps to dictionary definition. And I reserve the right to alloc these, but there are some free now. And I reserve the right to alloc to these. There are not many free. See keyboard devices. File, keydev.dd. The editor mostly stays in a getKey, /putkey, loop. The put portion is where keys are acted upon. TempleOS has a chain of put HNDLRS in a circular queue with priorities. The highest priority HNDLRS can choose to terminate handling, otherwise, the keys get sent on down the chain. KeyDevAdd defines the put device with a priority. Device might be a misnomer. Currently, the following are defined. Priority HNDLR 0x20000000 myPutKey, user HNDLR 0x40000000 keyed input filter PutKey, for in, inster, and in file, handling. 0x60000000 k draw PutKey, non-window direct to video MEM debug output. 0x80000000 k to PutKey. Standard document CMDS since handling individual keys is slow, TempleOS supports puts, as well. If no puts HNDLR is defined, individual keys are sent. cdoc.user_put_key and cdoc.user_put_s are callback routines which offer some neat tricks. c:/app/somebody/jukebox.hc. There is a var cdoc.user_put_data which gets passed to them. File, lex.dd. The compiler's lexical analyzer can be used in your programs to simplify parsing. See doc parsing or parse of code file. See tokens. File, memoverview.dd. Memory overview paging is practically not used. 64-bit mode requires paging, however, so it is identity map virtual identical to physical. All tasks on all cores use the same page table map, just as though all addresses are physical addresses. 2 MEG or 1 GIG page table entries are used. Nothing swaps to disk. In TempleOS, the lowest 2 GIG of memory is called the code heap. TempleOS's compiler always uses 32-bit signed relative JMP and call insts because 64-bit calls take 2 insts. With signed +/32-bit values, code can only call a function within 2 GIG distance. Therefore, TempleOS keeps all code in the lowest 2 GIG memory addresses, including what would normally be called the kernel. 2 gig is plenty for code, don't worry. You can create new, independent heaps using heap control in it. Then, use the cheat control as the second arg to malloc. See heap log, for an example. Memory list by a task will be freed when the task is killed. The atom task is a task that never dies. Its memory is like kernel memory in other operating systems. CACLOC, AMLOC, AMLOCIDENT, and ATRNU. All of the regular page tables are marked cached. When accessing hardware, however, you need uncached page table. The lowest 4 GIG addresses have an alias to access hardware located toward the top of map space, 0x10,000,000,000. CDEV uncached _alias. During an extended powered-on session of TempleOS, in theory, memory will become fragmented, requiring a reboot. It has never happened to me. See memrep and /demo/memdemo.hc. Single system-wide MEM map 0x000007C000x00003616F kernel module, placed here by the bootloader, boot_ram_base. 0x000009660000x00000996FFF boot block relocated here before loading the kernel module, boot DVD and boot HD. 0x000009700000970030 multi-core startup vec code, mpn_vec. 0x000009F0000009FFFF extended BIOS data area. 0x000000x000000BFFFF VGA graphics MEM with alias at text.vga_alias. 0x00000000x00000101FFF syspacket area for miscellaneous 0x00005000x001FFDFFFF code heap MEM. 0x00000000x00FFFFF 32-bit devices could allot memory at 0xF0000000 going up, but this is wrong, since some PCs already have devices at 0xF0000000. No PCI devices are supported, so MEM32 dev-alloc flaws are not an issue. 0x0080000000x00DFFFFFF 0x0100000000xFFFFFF data heap MEM. The physical memory that exists in this range is data heap. 0x10,000,000,000x100FFFFFF uncached alias of first 4 GIG. For 32-bit device access. 0x100FFFFFF 64-bit devices are a list with MEM64 dev-alloc, counting BWD, but no PCI devices are actually supported. Asterisk note, there is a break in the data heap block pool. This has no effect except the obvious effect that fragmentation has on contiguous requests. I can malloc an 8 GIG chunk on my 12 GIG machine. I can malloc an 32 GIG chunk on my 64 GIG machine. Asterisk note, For systems with less than 2 GB RAM, the code and data heap block pools are the same. For systems with 2-4 GB of RAM, the code heap is 1/4 of the total. CBLK pools in it. History: in 2003, I wanted to make a no paging ring 0 only 64-bit operating system for super speed with simplicity and full access. With paging, every memory request requires 5 accesses. It must access the address itself, 4K, 2 MEG, 1 GIG, and 512 GIG page tables, but the CPU's translation look-aside buffer mostly removes the penalty for using paging. So, I did not want to use paging, but long mode requires it. I did the next best thing. I identity mapped everything and achieved the simplicity I was after with subtle performance boosts, not wasting time changing address maps. And I look forward to the day I command Intel to make an optimized no paging long mode. I needed BGA 0000 BFFFF memory to be write through and 0xe000000-0xFFFFFFF to be uncached for various devices. All 64-bit computers allow stopping address translation at 2 MEG page size, not using 4K. I wanted to use 2 MEG for everything because it's faster, with one less level of page tables. I had to make a 0000 BFFFF write through, though, so I could not use 2 MEG size on the lowest page. I did the lowest 2 MEG area as 4K pages. I also unmapped the first 4K to cause a fault when dereferencing null. In 2016, I came up with an alternate idea. I double mapped the lowest memory with an alias that was uncached. Accessing the lowest 2 MEG area directly was cached, but the alias I created up at the top of address space was uncached. See uncached alias alloc. Unfortunately, I could no longer boast of the simplicity of identity mapping everything. Since many of my users are familiar with a 0000 BFFFF, it is actually pretty seriously unfortunate that they cannot use the easy-to-understand numbers of a 0000 BFFFF, but must access the relocated alias location. See text.vga_alias. I also no longer cause a fault when dereferencing null. Then, I switched to 1 GIG page sizes. For the lowest 4 GIG, I set up an alias up at the top of address space. See uncached alias alloc. Not all computers support 1 GIG page tables, however, so I also support 2 MEG. My original plan was to allow changing the page tables as needed, so I had code for taking control of 2 MEG pages and marking them uncached or whatever. When I did HD audio driver, I requested some 32-bit address space as uncached. Today, all of the first 4 GIG can be accessed without caching at the DEV uncached_alias. File, menus.dd. A pull-down menu appears when you move the mouse to the top of the SCRN. Menus are created with menu push, menu file push, menu new.
File, mouse DD. MIS-POS X and MIS-POS Y can be used to access the X and Y coordinates of the mouse. They are relative to the SCRN, not window. These can be used if you don't want to use MSG parsing. MIS-POS Z is the wheel. MIS-POS_text X and MIS-POS_text Y are the text column and row. C. Skeptical smiley demo /games/maze HC. C. Key M statigalbeals and key M shard statigalbeals. The hard designation, as in mis_hard, represents hardware layer items before the application of an abstraction layer. // mis_hard POS X equals mis_hard prescale X mis_hard scale X mis_grid X_speed. MIS-prefab X equals to I64, MIS-scale X mis_hard POS X, plus MIS-offset X, if, mis_grid snap, MIS-POS X equals truck, MIS-prefab X / mis_grid X, asterisk mis underscore grid x plus mis underscore grid x underscore offset, else mis POS x equals mis prefab x, forward slash asterisk 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 asterisk. File, MSGSDD. There are a maximum of 63 message types, so a bit mask can be passed. Messages have 2 args. See message codes. File, multicore DD. TempleOS does master-slave multicore instead of SMP. Core 0 is the master. The master core's applications explicitly assign computational jobs to other cores, and the TempleOS scheduler does not move tasks between cores. There are multi-core safe locks for file access and heap allocations, however, so TempleOS is symmetrical in some sense. See skeptical smiley demo / multicore / load test HC. Only tasks on core 0 can have windows, but other cores can help render them. Each core has an executive set task which is the father of all tasks on that core. Adam is the set task on core 0. You give a job to a set task with job queue, and get the result with job resget. You spawn a task on any core with spawn. Note, you must use the lock Adam prefix when changing shared structures in a multi-core environment. The LBTS, LBTR, and LBTC ISTs have lock prefixes. The compiler has a lock feature, but it doesn't work well. See skeptical smiley demo / multicore / lock HC. See skeptical smiley demo / graphics / transform HC. See skeptical smiley kernel / multiproc HC. File, new ASCIIDD. New ASCII. We want to use one set for ASCII, scan codes and screen codes. 0 to 63, 64 to 127, shift 128 to 100 and ISE1, control 100 and ISE2 to 256, control plus shift no more alt key in TempleOS. Control left / right is already begin / end line. Control up / down is already top / bottom of document. What about function keys? We will use reduced keyboard, probably. God says clearest but the me chance none quos privily subjection possessor abolished. File, ODD. TempleOS has an advanced algorithm for integrating ordinary differential equations suitable for use in video games. Not scientific work. It also has some support for systems of masses and springs, to save you some work. See CMathOS and ODES update for an overview. See ODEC all derivative to see what support there is for masses and springs. See skeptical smiley demo / games / wrap HC. Skeptical smiley demo / games / rocket HC. Skeptical smiley demo / games / math spring HC. Skeptical smiley apps / span main HC or skeptical smiley apps / Excalibur Excalibur HC. File, once DD. Kmain includes skeptical smiley start OS HC includes tilde / make home HC includes tilde / home sys HC calls startup task includes tilde / once HC calls once exec. A1 appends src code to tilde / registry HC once / Adam tree executed at next boot by Adam. 1. Appends src code to tilde / registry HC once / user tree executed at next boot by first user term. At boot, once exec executes once / Adam tree exit executes once / user tree and once /s. File, options DD. Compiler options use option. You might need to do #exec option. opt_glbls_data_heap. Without this option, global vars are placed in the code heap, which is limited to 2 gig. In AOT modules, global vars take up room in the .bin file, so you might want to use this option instead. You might wish to turn it on and off around specific vars. A disadvantage of data heap global vars in AOT modules is they can't be initialized. opt_externs_to_imports and opt_keep_private are strange options you will never need. They are to allow the same header file for kernel to act as externs when compiling itself and imports when compiled by AOT modules. opt_warn_unused_var warning if unused var. It is applied to functions. opt_warn_parenthesis warning if parentheses are not needed. opt_warn_dup_types warning if dup local var type stmts. opt_warn_header_mismatch warning if header does not match. opt_no_edge_var forces all function local vars to the stk not regs. Applied to functions. opt_no_built_I_const disable 10-byte float consts for pi log2_10 log10_2 load_2. Applied to functions. File pagdd. The word pag refers to an arbitrarily created mem_pag_size unit of heap allocation. TempleOS does not alter the CPU page tables after setting them up at boot in system_it_page_tables, so the CPU hardware page size is rarely important. File preprocessor dd. Preprocessor. There is no separate preprocessor path. The parser front end calls lex, which has the preprocessor built in. The compiler looks ahead a token, most of the time, so you might throw an extra semicolon after a directive if it's not taking effect right away. Put an extra semicolon #exe, cd, dir name, in case a hash include follows. #include. There is no angle bracket form of this directive. #exe will execute code at compile time and can be used to insert code into the stream being compiled using stream print. #define string const #assert print a warning during compilation if an expression is not true. #if include code if an expresio is true. #else #end if #if def. #if def include code if or sym is defined. #if eropt. #if hit include code if in AOT compiler mode. Defined is a function that can be used in expressions. #help_index. #help_file. See help system. See preprocessor. File printdd. Print fmtstrs equal to %0. H C strength print join. T truncate to. Add commas every 3 digits or 4 nibbles. $makes %q convert $ to \x24. / makes %q and %q convert % to %%. 4% %d or %u, the cause is thousands mode. %h, n will pick a var exponent multiples of 3 unit, while %h-3n will display milliunits or %h6n will display mega units. The K flag is always on 4% n. C. Skeptical smiley demo /print hc. 4% C or %c, the repeats the char that many times. %n floating point in engineering notation, exponents being multiples of 3. If it has a code, it will display scientific units letters. %s define, entry. %c to upper, character. %h 25 degrees Celsius, \n, 25 new lines. %h *c, 25, \n, 25 new lines. %f text file by file name. %f dolby doc file in memory. %pptr. %pptr with no offset. %p-link to ptr. %p-link to ptr with no offset. %d-date. Parser c-date. %t-time. Parser c-date. %z sub_entry of an enumerated list of text entries. CLST sub. Parse sub_entry _num first, list second. %z define lst load, sub-entry. Parse sub_entry _num first, define _name second. %q convert \\ to \\ and quote to \/ quote.